Hello, everyone. Welcome back to my daily coding series. Today's day 69. So I'm going to look at just another somewhat random problem here. So I saw this one, sort colors. I haven't looked at it. The title just looked interesting. Okay, so I want to lay out some goals. So I'm going to try to get it around 20 minutes would be ideal. And I will stop at 30 minutes. Yeah, so I'm going to do my problem solving in the IDE or just in a document as opposed to using MS Paint to mimic the interview setting. And I want to avoid overcomplicating things and over optimizing too quickly. So it's okay to write ugly code at the beginning. It's something I should remind myself of. Okay. That being said, let's start. So this is 75 sort colors. Given an array nums with n objects, colored red, white, or blue, sort them in place so that objects of the same color are adjacent, with the colors in the order red, white, and blue. You will use integers 0, 1, and 2 to represent the colors. You must solve this problem without using the library's sort function. So it seems like we just need to sort it in place. Okay, so it's basically like implement a coding algorithm that sorts it in place. So the only sort algorithm I know is merge sort but I don't think that's in place. Quick sort, I don't remember the logic of, and I don't remember if it's in place. So I'll say maybe in place. There's also, I know, insertion sort. And insertion sort is that is in place. There's bubble sort, which is also in place. Okay, so I know that this one is n log n. Quicksort is worst case n squared, but I still think it's fast on the average case. All right. So I guess the way I'll handle this problem is I'll try to derive what I remember of quicksort and implement it and make sure that it's in place. Merge sort. Can you do merge sort in place? I don't think so, because the whole idea is so merge sort, you split it up. So what I'm doing is splitting it up into two separate ones. That would be one. So that's the idea, and then you merge them. So I'm wondering if there's a way to do merge sort in place. So then you'd have 2, 0. So you would basically just have like the pointers there. And then you would sort this. And then you know that this is sorted, so you'll combine it. So now you'll do so then you would sort these and you get 0, 2, 1, 2, 1, 0, and then you'd sort the last two and you'd get 1. Well, you'd get, this would be 2 and this would be 0, 1, like that. So after you do the very end, like the leaf nodes, after everything is divided into a sublist of size 1, when you merge all of those, you get this. So now we know this is sorted, and this is sorted. So could we, and we've done it in place because we've just done 3 possible swaps there. So now what we do is merge this with this, right? We merge these two, and that would give us 0, 1, 2, 2. And then we would merge, so this wouldn't merge with anything. So that might be tricky. Like how to know. Because with this first case, it's easy enough. Like you just swap if you need, I goes up by 2, swap if you need, I goes up by 2. But if there was an odd amount, so there's either even or odd. And then from that layer, there's even, so that now there's either even or odd. So if it's, so in this case, we have an odd number of groups. So now it's grouped like, this. So we have an odd number of groups. So I think in merge sort, when you have an odd number of groups, you just merge the first 2 and then leave the last one as is. Now we have an even number of groups. So then we just merge the 2 groups and we get 0, 0, 1, 1, 2, 2. So we may be able to do an in-place merge sort. Also, something else to consider is that we only have 3 elements. So we might be able to, instead of using a sorting algorithm, we might be able to make some shortcuts because we know there's only 3 elements. So, I mean, I guess I just thought of a simple way to do it. It's kind of, it almost feels like cheating, but you can, I guess this wouldn't really be in place, but you could have just 3 variables like count 1, count 2, and count 3. Or I guess it would be 0, 1, 2. And then these would just give you the counts. And then you could just, so like, let's say this would be 2, this would be 2, and this would be 2. So you know, based on these counts, that your final array just has to be 2 zeros, 2 ones, and 2 twos, like that. Sorry about that. Okay. So 2 zeros, 2 ones, and 2 twos. I don't know if that's technically considered in place because we use these 3 variables. I would say that's okay. So, but this is a 2-pass algorithm because we pass once to get the counts, and then another to do it. Okay, so for the original problem though, we can do it in 2 passes. So I'll just do that because I think that'll be a simple approach. So we'll have this, and then we'll say for num and nums. So we'll do 2 passes. So we'll set all of these to 0, and then we'll say I mean, I could use a dictionary. For some reason, that feels like I'm using n space, even though it's 3. So we'll just say counts is a dictionary. And we'll set 0 to be 0, 1 to be 0, and 2 to be 0. Then we'll just say counts of num plus equals 1. All right, so this will get us counts. And we know num has to be either 0, 1, or 2. Okay, so that's the first part. So we're at 10 minutes, so that's quite a lot of time. And then what we want to do is so I guess we could say like current num equals 0. All right. Bluetooth is going off. All right, so current num equals 0, and then we'll say while I is less than length of nums, we'll say nums of I equals current num, and then nums of, we'll say counts of num minus equals 1. So what I'm going to do is add it. So we'll add 1, subtract 1, add 1, subtract 1, add 1, subtract 1. And then we'll just make sure, we'll say if counts of num equals 0, then, so it should be current num. Current num plus equals 1. Yeah. Okay. So while counts of current num, okay, so we're going to loop through everything. If counts of current num is 0, then we just move on to the next number. And what we're doing at every step is nums of I equals whatever our current number is, and then we're decrementing the count by 1. Okay, so let's see if this works or what this gets us here. All right, let's try submitting that. Yeah, that makes sense. So this should be a while loop as well, because we want to keep going until our and then if the counts of 2 equals 0, this can't, so this should never be 2. This should never print 2, because just the, okay. How do I see my output? All right, I guess I can't tell, but so my point is this should never be 2, because this will run once for exactly everything that's in there. Okay, so this is O of n, but we're doing 2 pass-throughs. It's also like super ugly, I feel like, but that's okay. All right, so I'll give it a little bit to think of how I could do it in one pass. So just to make sure, so we are sorting it in place. Whoops. We are doing it in place because we never, yeah, we just modified nums. All we do is just have counts of size 3, which is constant. So we do have constant space. But the only trick now is, can we do it in one pass? So this to me seems like it would definitely be an easy problem. So I'm guessing that the bulk of the work would be doing it in one pass. Okay, it's 202110. So how could I do it in one pass? So my idea is like maybe we can set it. It's hard because we can never go backwards. So we have to know. Well, we can swap things, but maybe we could use an idea of a pivot or something like that. So we could So if I remember with quicksort, I don't really remember how the pivot worked. But is it like you pick a random number to be a pivot? And then if it's greater than that, you just put it on the right side. And if it's less than, you put it on the... Or maybe you put the last number is supposed to be a pivot. Yeah, I don't quite remember. Yeah. To be honest, I think I'll just leave it there for today. And I don't feel like I have any insights on how I'd be able to do this. I'm not that great with my sorting algorithms. I'll definitely try to look up quicksort. I'm not saying that quicksort would definitely solve this problem or anything like that, but I should know how that sorting algorithm functions. But yeah, so this problem was, I feel like my way of doing it was kind of cheesy. But it does fit the requirements, so I guess sometimes that's okay. Yeah, so thank you guys for watching. Today was day 69, and I'll see you guys tomorrow for day 70.